I'm really sorry that I can't be with everybody there today. Unfortunately, my flight this morning was canceled, and I had a tight schedule, so I couldn't actually get there before that. So unfortunately, you'll have to take the virtual me as the proxy for the real me there. But at least you can hear some of the messages that I have from some of the work that we've done in educational games over a bunch of years now. And then please do know that if there's anything, you can just people can jump in via chat. I'm going to also just turn off my do not disturb here so nobody disturbs me. So thank you for having me there virtually. I'm going to be talking today about some of the design principles we've used over many years in designing games that resonate with learners. We have a book coming out called Resonant Games. Actually, now it's been delayed again until next month, but it chronicles a lot of the work we've done in educational games, some of which I'll talk about today here. Just to give you a sense of who I am and the program I'm with, I run a program called the Scheller Teacher Education Program and a sister program called the Education Arcade. And what we do in both of these programs is it's a matter of enabling playful and meaningful learning experiences using the affordances of new technologies. And so I put the learning experiences first and the technologies second. What we do is look at ways of using interesting and new technologies. In a lot of our work, we really try to have the educational experience be the thing that drives and not the technology itself. We do, I'd say, three big parts of our work are designing and creating new experiences, implementing and scaling experiences, and developing capacity for more experiences. And sort of integrated into that is a series of research processes, which is really design-based research. So this idea of sort of thinking about problems in real systems, being able to implement and sort of scale some of those things in there, and ways of iteratively working on that is what design-based research is. It is our primary way that we do research in our lab here. For those of you that don't know design-based research, this is the basic process of design-based research. You'll see here, and these arrows are taking through a cycle. It starts with the analysis of practical problems. It moves to the development of potential solutions, iteratively testing and redesigning in practice. The practice is a really important part of that. This is not something that happens in a lab, but happens out in the field with real problems. And finally, it's reflecting to distill design principles. So the goal isn't necessarily to only have a product in these cases, but to also think about some design principles that helps us within our own group, but hopefully also lots of other people design similar experiences based on those outcomes. And you'll see here that there's this refining process that comes throughout here. You don't necessarily go all the way to the end and then all the way back to the beginning. You can sort of shortcut this at several different cycles when you might go refine and do things again. So today, what I'll be talking about, I'll quickly talk about the evolution of digital learning and how that impacts the way that we work in terms of technologies. I'll be talking about the ideas of creative play and invention that drive a lot of our work, and then talk about this potential conflict between learning and games, and then get into the details on resonant games, and I'll just talk briefly at the end about making games and simulations. So evolution in schools, and this goes across the sort of from preschool on through adult learning. There's been sort of this chasing of technologies to define what we're actually doing in these classrooms. So it was about, we need to have labs full of computers. We need to have everybody have a laptop. Everybody's going to have some sort of small netbook. Everybody's going to have a tablet. Everybody's going to have a Chromebook now, as a lot of schools are chasing. And it's been the technology that's driven the pedagogy, the technology that's driven the ultimately the design, which is in most ways, really backwards. Along with that has sort of come what I might say an evolution of learning, which is a de-evolution of learning. So this is, if we look really back at some of the early stuff that Seymour Papert did, the very early stages of educational technologies. Seymour Papert was one of my predecessors here at MIT, a really pioneer in educational technologies in the 1960s and 70s. He invented or co-invented the logo programming language, which you'll see here on the screen, in one of its earlier versions, where you had this turtle that was on a screen and you could draw different shapes with it. And his idea was empowering kids with sort of powerful mathematical ideas that they could be able to express and create things themselves. And if we look at those same concepts today in the way that they're taught in many schools, it looks more like this. where you're sort of watching a video and then you have to answer some multiple choice questions about geometry. And this is I think, sort of the opposite of the ways that we sort of be thinking about educational technology. So rather than empowering kids to be able to do the more expressive things and really learn in creative ways, which are the kinds of things we need to be able to teach them in the 21st century, it's devolved to this rote memorization and question and answers, which is not necessarily preparing them for the careers and the futures that they have. Some of this has been powered by media consumption devices. Again, the devices sort of control a little bit of what's going on. So if we have tablets and things like that that are our primary devices with limited inputs, we often can sort of come quickly to say, well, they're really only good for watching videos, so we should just have people watch videos on those. But in fact, I think people are becoming more creative in terms of the uses that they think about with even these devices. And we also have a generation of media consumers growing up here. This includes my own two kids. In the middle and on the right-hand side there, and my nephew on the left-hand side at a recent games conference here in Massachusetts. We have our big games conference, which is PAX East. It has, I think, about 100,000 people that come to the games conference. And while they're media consumers, I will say that they're critical media consumers. But we have sort of raised a generation of people who have media at their disposal and in many cases become consumers of that media. And all this, as I mentioned, is sort of opposite of the way that we want to be thinking about the positioning of the 21st of our students in the 21st century. There's lots of different frameworks that we can think about for the kinds of skills and the kinds of practices that we want our students to be leaving our institutions with. But they certainly include things like creativity, communication and collaboration, information literacy, citizenship. These are the kinds of things that we want our students to be leaving with. And if you look at the kinds of all the kinds of data that's coming from workforce, that's coming from industry, that's coming from digital citizenship. I mean, they're all sort of pointing towards these sorts of things, and not necessarily to, if you don't necessarily know how to calculate angles in a particular parallel lines within a geometric shape, that may not be the critical thing. But if you can't do these things, this is really going to be a problem for a lot of our students in the future. So what I think about is ways of sort of using some of the power of games and gaming culture to turn passive media consumers. This is really popular websites here. You'll see this one's a few years old at this point, but some of these some of these videos. This top one has 4 million views. So people watching other people play games is a huge industry online, both through videos and through esports as well. And so what we want to do is sort of use that interest in that interest in watching to turn people into interesting creators as well. So they can use that knowledge, that passion that they have about the things that they're working on and working with to make things themselves. This was one of my own kids, his Minecraft page. After he watched those videos, he got inspired. And then decided that he wanted to also make videos and curate videos as well. So that's I think in many cases people say it's really only kids should only be designing games, but I think actually kids playing in interesting games and learning about interesting games is an important part of the process. It's not just about creating, but it's about a whole process that involves playing, designing, and creating. So what does creative thinking look like today? Should we just do this? This is the Logo programming language I mentioned earlier. Should we just sort of say, okay, let's take that old screen and sort of cram it onto a cell phone, and that's what it should look like, and problem solved? We could do that, but it really I think it looks more like this. So this is Minecraft. I'll come back to a couple times in here. It's one of the, I think, better educational games, even though it wasn't designed as an educational game. This is Minecraft on a phone, which actually works pretty well. It was not designed initially for phones, but it works pretty well on that. And if you're ever sort of on an airplane or in a school group, you'll see kids playing this game on their phones or their tablets. And I think this is more what creative thinking should look like. We should be thinking about ways we can use these powerful devices that we have with us to empower kids to do interesting and creative things. In many cases, you'll see kids even playing with each other on these. You can create shareable worlds where you can work on things together. So all those skills I sort of mentioned on that previous couple slides ago about ways that you can be all the 21st century skills, a lot of those things are embedded in these kinds of systems. And it isn't just Minecraft. I mean, you can think about lots of different games. Some of them, whether it's specifically educational games or great games like World of Warcraft that also involve lots of those skills, or even some of the tablet-based games. This is one in the upper right there. as Bad Piggies. It was probably the best of what I think was the Rovio games. Rovio invented all the Angry Birds games. In this particular one, you sort of take the opposite perspective, and you're doing this whole sort of series of invention activities where you have to protect the piggies through various design and engineering challenges. It also involves, I'll primarily talk about digital games today, but there's certainly a resurgence in tabletop games, paper-based games, board games, card games. There's a really great industry going on around the world at this point. You'll see things like on Kickstarter. You'll see conferences about these kinds of things, and I actually think that board games are an interesting complement. And in my own classes here at MIT, we do design activities both in digital games, and we do stuff in paper-based tabletop games as well. And I think those are both interesting media. And then also creative invention, as I mentioned. This is Game Blocks, invented by a former student of mine, which is a system for kids creating games, a lot like Scratch, if some of you have seen Scratch. And I'll talk very briefly about this stuff at the end. So when we think about games, I know this is an audience that sort of knows something about games, but I still sort of like to start off with this, how I think about this. So when people think about games, they often think about something like this. It's a 3D first-person shooter. It's maybe played by boys in basements as they drink Mountain Dew and drink Doritos, and that's what video games are. And to some extent, that's true. And then when you think about learning games, they say, well, how are we going to make a learning game out of this thing? Well, let's put some educational content into this, and it will become a learning game. So if the soldier has to ask how many volts he needs for his laser cannon to kill 3 times 6 opponents, then this will become an educational game, and this is what we should be thinking about in that case. But this is not what I mean by games or educational games. And I think some of this actually comes from this what I call the legacy of Math Blaster, which is probably the most commercially successful educational game of all time. It's had many iterations over time. And the idea in Math Blaster was you had these math problems, and they floated around in the sky, and you had to match the answer on the asteroid or meteor or whatever it is to the equation at the top of the screen. And it was really a clear case where the play was the reward for learning. There's no connection between shooting things out of the sky and these mathematical problems. And these could be biology vocabulary words. They could be chemical equations. They could be historical facts. Anything could float on these things, and you could sort of answer them equally as well. And so really there's a big disconnect between what's going on inside the game system and the learning that's going on here. And this is what has been referred to as chocolate-covered broccoli. So the broccoli is the thing that you want kids to learn. You want people to learn. It's the stuff that's supposed to be good for them, and the chocolate is the stuff that you want to motivate them with. So the chocolate here is you get to shoot things out of the sky, and you sort of create this idea that at some point kids will maybe be more likely to eat this broccoli because it has chocolate on it, and they'll get the good stuff along with the chocolate that's going to be motivating them. And to some extent, you might actually get kids to eat broccoli this way. You might get kids to do some math problems this way. But it doesn't promote healthy eating or healthy learning. And the question is, what happens when the chocolate goes away? So at some point, the chocolate does go away. At some point, you don't have the motivation to do those math problems anymore because you're getting to shoot things out of the sky. And at that point, you're left with just broccoli. And what we've taught kids in the meantime is that math isn't fun. We've taught them that the only way you should be able to do math is if we motivate you with getting to shoot things out of the sky. Instead, what we should be really teaching them is that math itself is fun. How can we actually make learning itself fun and playful? We need to sort of this is my poor analogy here, we need to sort of take what's really deeply integrated about the broccoli and the chocolate, the cocoa, and integrate them at a much deeper level and make them much more one and the same thing. In other words, not two different things. I think a great example of this is a game co-invented by my colleague Scott Osterweil here in the lab a number of years ago and re-released a couple of years ago, The Logical Journey of the Zumbinis. It's a game all about mathematics, but you'll never see a mathematics problem on the screen here. So you have these different characters that have different characteristics. You have to get them through different obstacles. That's all based on mathematical systems, but you never see the math problem on the screen. It's about sort of figuring out the math that's embedded within this world. And that's really the way we should be thinking about teaching things like mathematics, is not by sort of putting the problems on the screen and asking for them to shoot things out of the sky with them, but really thinking about what are the kinds of interesting mathematical systems that we can have learners play with. I I think also part of this comes from this idea that this is what the joy of gaming looks like. But in fact, this is what the joy of gaming looks like. So it's not about people throwing their hands in the air and having fun. The bottom here is the faces of two gamers from a photo essay somebody did on faces of gamers as they were playing games. The top there is my daughter at that same video game conference a couple years ago. It's this idea on their faces that's what some people call pleasant frustration, or what we call hard fun, also after a phrase coined by my colleague Seymour Papert. The idea that you're not having fun in spite of what you're doing being hard, but because it's hard. You're wrestling with challenging problems, you're overcoming those challenges, and that's where the fun comes from. I'll just briefly say that, so the idea here, for those of you that don't know the zone of proximal development, I'm assuming many people do, this idea developed by Vygotsky that you sort of have a set of things that you can and will do by yourself. You have on the outer sphere there, you have a set of things that you can't or won't do at all. And in the middle, you have a set of things that you can and will do with help. The idea is that we want to do is through games, is to get people to sort of grow that inner circle of things that they can and will do by themselves. Not that we'll sort of like make them only be able to do things with help. The idea is that over time, that inner circle should grow and not shrink. So part of this we do through the structure of games. So as I said, games is not just about sort of having fun all the time. Instead, we think about games as really well-structured environments. And sometimes people sort of say, well, when we make a game, we're going to think about some sort of dichotomy. Again, this is some work from my colleague Scott Osterweil here. And the idea that we can either have things that are more towards the end of educational, or we can have them sort of be more fun and open-ended. And we can think about it like a pizza where you can have two different toppings, and if you want to have more peppers, you have to have less pepperoni, or vice versa. But instead, we sort of think about this as a two-dimensional space. Where learning and structure are on one axis and fun and play are on the other axis. And in fact, you can have something that has some of both. Those are, in fact, because it's on two axes, you can have things that are both really not fun and not much learning in them. Or you can put things sort of all the way up here where you have a lot of learning and a lot of structure. And those things are not antithetical. They can, in fact, be complementary. And we actually have some research, I think, that I'll point out a little bit later on, that shows how that can be the case. So this idea that structured, goal-oriented, feedback-driven situations can be fun. In games, we sort of willingly submit to some sort of arbitrary set of rules if we can continue to be playful in the process. And we point to the example of golf, where in golf, and I'll bring up my daughter here. The idea is you have this stick, and you need to be able to hit the ball to a hole that's really far away, and we sort of do that. Those are the rules we play by. Even though we know that it's much easier to just pick up the ball and put it in the hole. That would be a much easier thing to do, but that's not fun. It's because the game itself is structured around a set of rules that provides us with sufficient challenge, where the challenge itself is the thing that creates the fun situation for us. That the challenge itself is not so difficult that we will never succeed, but it's not so easy that it's not any fun either. And that's what makes for a compelling scenario. And that's what we try to do inside of games. We also sort of know that it's not just about formal games, and in fact, the way that scientists sort of play with ideas is very much a playful idea. So this is a quote a number of years ago. Playing with ideas is, after all, what science is about. If I walk around the laboratories here at MIT, I don't find people just sort of in their white lab coats sort of writing hypotheses and doing experiments. I see them playing. I see them playing on whiteboards. I see them playing with different kinds of materials in their laboratories. I see them playing by talking to other people about ideas. It's very much playful in the way that new ideas are generated. And this is what motivates us as scientists, as people, and that's what we try to do in the scenarios that we create for students. So I think about actually 5 criteria for the structure of games. The first one being interesting decisions. This is Sid Meier, who created the game Civilization. This was his big hallmark for it, that they're interesting decisions, not just decisions. This isn't just heads or tails on a coin. This is about it's something that's interesting. I have some information coming in that helps me think about that decision and why I might make particular kinds of decisions. There's consequences to those decisions, so I can be either rewarded or punished based on the outcomes that happen there. There's some sort of clearly defined goals. There's or some sort of rules or constraints. I make sure that word is plural, because I think actually good games have multiple different kinds of goals that people can pursue. Going back to that example of Civilization, there's many different ways to win the game Civilization, and I think that's actually really interesting. there's visible, measurable feedback. So sometimes when people think about a game, they think about, well, you have a score. But in fact, in most games, and a lot of good games, you have many ways that you get feedback. So you might have a score, but you might also have a wealth meter. You might have a health meter. You might have a gear that you've collected. You might have outfits that you're able to wear. You might have friends that you've been able to make in the world. There's so many different ways that you can sort of measure your success within the game. And you can actually weigh, as a player, you can weigh those different kinds of feedback in different ways. And finally, there's some sort of underlying model or system. In many cases, as we do work in science, and those are based on a simulation, but that can really be sort of just any sort of consistent set of rules. And then we have a spectrum. So rather than saying things are games or are not games, we sort of say things are a little bit like games or a lot like games based on the characteristics that they hold of this list here. So specifically within this idea of resonant games, we have a set of like four big top-level principles that we've outlined here. And I'll illustrate these. I'll go through them at the beginning here, and then I'll illustrate them with some examples. So the first is designing for the whole learner. So we think about not just, this is a student in my class for 50 minutes, but rather this is a person who has a life outside of my class, as well as their opportunity in my class. So I know about how old they are. I know maybe something about the kinds of music or books or videos that they like to watch. I know something about the kinds of social connections that they have. I know something about the other media they like to use. So when I think about that design, I think about that whole person, not just the person who's going to be in my class for those 50 minutes. I think about designing for communities. So the idea here is that learning is very social. So learning is not something that happens with an individual in front of a computer, but something that's part of a much larger system connecting with other people. Now, sometimes that is in multiplayer games where I explicitly connect with other people inside those games. Other times it's a matter of showing somebody the screen on my phone and to show them the success that I've had, or sharing an accomplishment on a social network. So all those things sort of help create some of the things around communities. It's designing for knowledge, skills, and practices. So oftentimes, as I sort of showed in some of the sort of classical examples there, that educational games focus solely on knowledge. It's about sort of delivering content, which is an important part. I don't want to say that it shouldn't be something that we focus on at all, but it shouldn't be the only focus that we think about in designing educational games. We also have to think about the kinds of skills and practices that people learn in those, and those are the things that are more durable and transferable, particularly as we think about the rapid changing of information in society today. And finally, we think about designing for society. So it's not just about designing for a learner who's in my class for a very short period of time, but honoring the fact that these things are all part of a way that people are inside of society. So there's real concerns that they have. There's relationships that need to be respected. There's the position of these people in their own society and what they want to do to make the world a better place, or a different place for that matter. And all those things are things we need to think about as we're designing. So I'll give examples, one or two examples in each of these different ways. So one is designing for the whole learner. This is a game called Labyrinth, again, led by my colleague Scott Osterweil here. The idea here is that it's a game where you have to save your pet from this factory. And there's just a little bit of customization that happens up front as you're sort of thinking about who this player is and what they're doing. But we also thought about kids at this age are reading from comic books, so we made the game all about sort of in comic book format. We thought about the kind of length of the experience. There's a lot of different factors that we thought about that were customized to that particular audience. Another case here, this was a game called Vanished, which was an alternate reality game that was designed in conjunction with the Smithsonian Institute. The idea was it was a game that started with a video from some MIT students that said, so there was an opportunity to sign up for this game, and then the day the game was supposed to launch, we had this video instead that said, "We're really sorry, we don't know what happened. Our website was hacked. If you have any information about it, please, we set up these forums. Please post something in the forums and let us know." And in fact, in the video at the top of the screen for just a fraction of a second was a code. And that code, people had to realize that they had a code, and they would post, "Hey, did anybody see in the forums I had, AZQRRF in my video?" People would say, "No, I had a different code." And it turned out those codes, there were 100 different codes. Each person only got one. You had to link them together, and then you had to realize it was a cryptogram, and everybody had to decrypt it together. And over the next 8 weeks, players had to be able to take citizen science data in their backyards. They needed to go and visit museums. They needed to figure out measurement systems. They were ultimately communicating with these beings from another planet who knew nothing of our unit system. So they had to come up with ways that they could calculate things like temperature and distance. They played some games online. They interviewed scientists. All these different things that they did, and as a result, all those different things were different ways that different people could contribute. So if you wanted to be the person who contributed in the forums, you could do that. If you wanted to be the person who collected data in your backyard, you could do that. If you wanted to be the person who went to the museum, that could be you as well. So each person sort of had their own way of customizing the experience to the things that they liked the most. Designing for communities. So if you think about the kinds of games that many of us play on our phones today, so many of those involve some sort of social component. So either it's real-time, this is Clash Royale, a game that I've fortunately don't play anymore. I played for quite a while. It was very addictive. But it's a game where you sort of play against other people in real time. So there's some social aspects there, but you also have these groups of people that you work with to trade resources and knowledge as well. So it's a very social game. You think even about things like Candy Crush. While you may not play against other players, it's about sharing your accomplishments and social networks. They all sort of have really important parts that are quite social. So we've designed games where we try to do the same thing. So these are games that we designed that are UBIC games. And the idea here was that you're playing these games in very much the same style as you would sort of casual mobile games, where you play the games for short periods of time, but frequently. You don't play them in class. You play them between class, before class, after class. And the idea is that the teacher has data about what's going on inside the game. So the one on the left is about DNA and RNA. The one on the right is about genetics. And these games, in some cases, we had not these two particular ones, but some cases they're explicitly multiplayer. But there's always some aspect of sort of engaging with other players as part of these games being mobile and social. I won't talk too much about this, but I will say that we designed a whole series of games here, and we sort of looked at different kinds of learning games. We did ones in genetics, DNA, evolution, ecology. And the details here aren't important, but only to say that while we designed games using similar kinds of methodologies, we found that actually they had really different learning outcomes. Some of the games really mattered in terms of the learning outcomes. Other games didn't matter at all, or only mattered under some conditions. And it's really important to sort of think about the design principles. And here, and I think one of the most important design principles we ultimately learned was it's not a matter of repetition. It's a matter of games actually challenging people. So if you remember my picture of the zone of proximal development, if you can keep people in the yellow zone, if you can keep people expanding their what they're doing with sort of aid, then that green area grows. That's where you sort of have the learning gains. If it's a matter of just keeping them through repetition, the gains don't seem to be there, at least in the examples that we've done. Okay. Again, another example of knowledge, skills, and practices. I mentioned earlier the pizza diagrams, as I call them, where we're looking at can we increase both the sort of learning and knowledge that people are doing in the games, as well as the fun and engagement that we have. This is a game that we developed here with the Game Lab a number of years ago, along with my colleague Tim Marsh. It's a game, we actually developed a series of games called Whoosh and Waker, which were these platformer games that were about drawing motion displacement graphs. The only thing you need to know about this game is that there's a platform you need to get to the top, and that green glowing light there is actually a motion graph. And you can control that motion graph, and you actually need to learn that you can control that motion graph. But so it's about, this game is also about, so it's about those specific skills, but it's also about the problem solving skills that you have to learn along the way in order to be able to solve these problems. Again, I won't get to the details of this research, but I will say that what we did was we did research on these different versions of the game. The different versions had different amounts of educational content that were in the game. So some of them were just sort of a fun game. We never explained anything. Other ones, we had sort of a narrative where there were cutscenes. In other cases, the narrative with the cutscenes talked about the concepts that they were learning at the same time that they were actually playing the game. And we found that, in fact, that the versions of the game that had more instruction in them, not only did the students learn more, but they actually found those games more engaging. So in that case here, we sort of were able to push the game to the upper right-hand quadrant there. Also mentioned the same genre of knowledge, skills, and practices. I know there's several examples here. This is one of our more recent projects. It's part of a project we call Clever, which is about, it stands for Collaborative Learning Environments in Virtual Reality. So it's a virtual reality environment here where we're trying to sort of think about what are the advantages of virtual reality for engaging with learners. The idea here is we're starting with the idea of the cell. Our typical views of the cells look like the one on the left, where you have this very sparsely populated cell. It really looks a lot more like on the right. So we're trying to teach things about organelle design, the true density of cells, and the important concept of the relative scale. We think that, in fact, virtual reality, the sort of stereoscopic views that you have will actually be important in understanding the different scales that exist within a cell. So a lot of students sort of think about a cell as one size, like everything in the cell is all one size. But in fact, things within the cell itself exist at many different scales, and we want to be able to help them understand that. So part of what we're doing in terms of engaging with knowledge, skills, and practices, there are certain things we want them to understand about the cell, but we also want them to understand the kinds of tools that scientists use in engaging with cells. So we're giving them the tools that they have to interact with the cells are very much the same tools that scientists have to interact with cells as well. And ultimately, they get to sort of engage with those cells as if they were sort of real and understand the real constraints and the real affordances of interacting with them in that way. I won't take the time for the video at this point. Finally, resident games for society. I'll give a couple examples here. So one of these is actually a platform that we have called Tailblazer. Tailblazer is a platform for making location-based augmented reality games. So these are games that take place in real places on real maps. We've designed a whole series of games at all different levels for people thinking about health, environment, and a lot of community issues. We've done these with, as you'll see here on the screen here, adults, middle school kids. We did a whole series of projects on public health at the School of Public Health with Harvard over several years ago. But the idea here is that you're playing sort of games in real places. And in fact, we find that it really matters where you play the game and whether the players sort of have a relationship with that community. So if you play a game sort of about, where it's just like, okay, we're going to go out on a playing field and you're going to play this game and it takes place on Mars, it doesn't really matter necessarily that you're sort of doing this outside in the real world. But we've done a series of games about sort of environmental and health issues. And we do find that that when you sort of play it on your home turf, when you play it on the place that you know, the kinds of decisions that you make are much different. And in fact, they incorporate a lot of what you know about the community outside of the game. And players tend to sort of make decisions that are what we think about as socio-scientific decisions as opposed to purely scientific. So they encounter people out in the real world about their regular business, and they incorporate those kinds of people and what they might think about the kinds of situations that they're dealing with, even though they're fictional, in their thinking about the way they process the game. So really interesting results there. The last one I'll talk about here in society is Radix, a game we designed a number of years ago with the Gates Foundation. It's an online massively multiplayer game about math and biology. The idea within here is that you engage with different kinds of systems. So you need to sort of have genetic systems that help you breed plants and animals to make the world a better place. You need to sort of rebuild buildings. So you need to use geometry in order to be able to do some of those things. But it's a multiplayer game, and so it's about thinking about how you interact with other people. And even in this case here, where the society is a fictional society, it's all about sort of thinking about how you're actually applying these things in a world to make the world a better place. So it's about thinking about your role in that world as well as the specific tasks that you have at hand. In all these kinds of things, this is an important thing that I like to think about. Particularly when we design for society, but I think more generally as well. This is the action reflection cycle that many people think of from experiential learning, where you sort of do, where you might have some sort of outdoor education experience where you need to get a whole group of people over a wall without a rope, for example. In those cases, you have some sort of challenging action. You often fail at first through that challenging action. You ultimately sort of like debrief about why it wasn't working. You then maybe sort of get a chance to do it again. Ultimately, you have success, and you sort of move on to the next task at that point. But the idea is that just getting people over the wall is not the learning experience. That's just part of the learning experience. Similarly, we think of the games not as the whole learning experience, but as part of the learning experience. They are the experience itself, but you need to also think about the resources that you combine with those and the opportunities for reflection that you create as an educator. So the learning game itself is not the black box that sort of like makes students learn, but it's the experience that provides an opportunity to enable them to learn. I'll just sort of bring I'm going to bring it to a close relatively shortly here. But the idea, these are I mentioned the 4 top level principles we have in Resonant Games. We have quite a number of subcategories within each of those categories. And it isn't just a matter of sort of coming up with a diagram, like you must have a maximum amount of all these different things within this space here. So this is what that diagram might look for one of the games that we created. And we sort of might map that against another game that we created. And we sort of prioritize different sort of ideas within here differently. We think about things about authenticity. We think about the social nature. We think about the opportunities for partnerships or co-design. Each one of those things needs to have some representation within here, but we might say like this game is a really great opportunity to sort of emphasize the social aspects. So we're going to play up the social aspects a lot, and maybe, for example, that the connectivity or something like that will be maybe a little bit lower in this one. So we think about ways that we prioritize those and match them both with the game type itself, the learning environment, the needs of the learners, and the content area that we're studying. So I did mention that I will sort of make a little bit of a bridge to from playing games to making games, which we also think about. And I mentioned the Tailblazer as one place to do that. So Ms. Resnick has this great cycle here that he thinks about for imagine, create, play, share, reflect, imagine. It's this virtuous cycle that they think about for a lot of kids creating things, and I think it's really great. We often think about maybe the place that we actually get kids to start in this cycle is at the play part. By playing games, by having students play games, then they can actually create games. And some of those games, it might be about making modifications of a game. It's not necessarily creating a game themselves. It might be making a modification of a game. It might be doing a paper or analog-based game. It's not necessarily a digital game. But I think about sort of thinking about ways that we can harness some of the deep experiences that people have in play to have them also create those experiences. And there's plenty of platforms, I won't go into this, but there's plenty of platforms for doing this online for people who even don't have a great deal of programming experience, like with many of the block-based programming languages like GameBlocks or Scratch. So with that, I will say thanks for having me, at least digitally, there. I thank a lot of our funders for the work that we've been able to do. That's my Twitter handle up there, Klopfer. I'm on our website, education.mit.edu. And I will say thanks for having me. Yes, I'm happy to take a couple questions via chat here.
Great. This has been a wonderful presentation. Thank you so much. I'm wondering with the resident design, have you incorporated or will you be incorporating issues of racism, homophobia, misogyny and violence, and developing empathy with the players? I'm very curious about this.
So the question is, with resident design, will you be incorporating issues of homophobia, racism, misogyny, violence, and nurturing empathy in players? I think that relates to some of the issues around society. That's sort of the fourth big point there. So it is about sort of thinking about the way that this game is situated in a society that has real issues. Those issues vary from place to place. They vary at different kinds of scales. We're thinking about my local community, my global community, my state, my school. But I think that's definitely important in the process here, is thinking about this game isn't just something that happens in isolation, but that this game is played with a student who's part of a society, and those societies have real issues. Now, some of that stuff happens, I think, explicitly in the game design. If you think about things like misogyny, racism, and things like that, so some of that can be not only not dealt with in games, but it can be made worse by games. So we need to think about the ways we represent different kinds of people or different kinds of races, genders, etc., whether they're represented at all in our games. So some of those things are important, I think, even in the design of the experience. But certainly in the way that we think about the relationship between that game and the person who's playing the game, we also think about the ways, the kinds of messages and the kinds of actions that we think that will come out of that experience. I'm seeing some typing there. There's a lot of interest right now, specifically in that last issue of empathy. A lot of interest in virtual reality. Some people have called virtual reality the empathy machine. The idea being that if you experience what someone else is doing, someone else's experience through their eyes, through virtual reality, it's actually a more powerful experience than sort of seeing it on a screen. And I've seen some of these demos that people have done where you're sort of and you're role-playing a Syrian refugee or someone who's potentially much different than yourself, but seeing it really through their eyes. And I think the research so far has shown that actually it can matter. Now, I won't say that this is not a silver bullet. You can't just sort of take anything you want, put it in virtual reality, and it becomes a way to generate empathy. But I think sort of well-designed experiences that are sort of done in virtual reality in that way can actually be really important for help generating some of that empathy. Great. Well, thanks so much for having me. Thanks for the questions. Return to the questions.